Alright, so for the final video in this probability section, we're going to be looking at a conditional probability. And this is when we have a certain condition regarding a probability. So, for example, we might see this notation here. So this reads as probability of A given B. That's how you go about reading it. And so what it just means is, what's the probability of A occurring given that B has already occurred? So that's the condition, right? B occurring is the condition. And then we're looking at what's the probability of A occurring after that. And so if we were to ask to find this value, then we have this equation here. So the probability of A given B is the probability of A and B over the probability of B. So that's how you go about finding this certain value here. Now for independent events, the probability of A given B is B, and the probability of A given not B is also A, like this. Right, so what does that mean? Well, independent just means that there's no effect depending upon previous results, right? So if probability of A given B, it just means that even though B has occurred, it should not affect what the probability of A is going to be. So that's why we have these two conditions like this. So let's go about solving some questions. So we have C and D are two events, where the probability of C given D is a third, probability of C given not D is a fifth, and probability of D is a quarter. Find the probability of C and D, right? So this one we can use the given equation, right? So the probability of A given B was equal to the probability of A and B over the probability of B, like this. Now A and B can just think to yourself, it just represents any letter, right? So you can just interchange with any letter. So in this case, A is C, B is D. So if I was to rearrange this, the probability of C and D would be the probability of C given D multiplied by the probability of D, like this. C given D is a third, multiplied by D is 1/4, so it's going to be 1 over 12. Part B, the probability of C and not D, like so, okay? The same thing, okay, this is the probability of C given not D times the probability of not D. So as you can see, the A and B values can just interchange, it just represents any value. So just make sure you just write it or interchange it correctly. The probability of C given not D is a fifth, multiplied by the probability of not D. Well, probability of D is a quarter, right? So not D is going to be 1 minus a quarter, like this. And you're going to get 3 over 20 if you do this calculation. Right, C, the probability of C like so. Now it's best, even now, just to imagine yourself drawing some Venn diagrams. That way you can visualize it a bit better, right? This is C like this and D like this. So using what we know already, right? So the probability of C is going to be the probability of C and not D. That's what we found already. So C and not D will represent this section here, right? Plus the probability of C and D, right? This probability of C and D will represent this intersection part here. So it's going to be the sum of the first two values we got before. So 3 over 20 plus 1 over 12, and we get 7 over 30. Right, D, probability of D given C. So this is going to be the probability of D and C over the probability of C. D and C is the same thing as C and D in part A, so 1 over 12, over probability of C. Well, we've got that in part C, so 7 over 30, and you should get a value of 5 over 14. Right, E, probability of not D given C. So probability of not D given C, which is the same thing as probability of not D and C over the probability of C. Right, so probability of not D and C is the same thing as probability of C and not D in part B. So this is going to be 3 over 20 over probability of C, which was the same thing as part C, so 7 over 30, which would give you 9 over 14. And finally, probability of not D given not C. The probability of not D given not C is going to be the probability of not D and not C over the probability of not C. Right, not D and C will just represent this outer section here, right? This section out here, okay? So that just represents 1 minus the probability of D union C, which we learned in the previous video, over 1 minus probability of C to get probability of not C. Right, 1 minus D union C. Remember the addition formula we learned earlier? Remember, so this is the same thing as probability of D plus the probability of C minus the probability of D and C. So it's going to be, probability of D is going to be a quarter plus 7 over 30 minus 1 over 12 over 1 minus the probability of C, which was 7 over 30, and we should get a value of 18 over 23. So as you can see from all these calculations, we just bring in all the different formulas that we've learned before, including our use of Venn diagrams. So I'd always suggest drawing a Venn diagram just so you guys can visualize the question a bit more easily. Right, let's try this question here. So we have the three events A, B, and C, and we're given each probability, and we're also given the probability of A and B is 0.3. Given that A and C are mutually exclusive, so remember mutually exclusive is when they do not overlap, right? So the property of A and C is going to be equal to 0. The property and the B and C are independent. Okay, so B and C are independent events. So for part A, find the property of B and C. Right, if it's independent, we know that this should be equal to the property of B times the property of C, right? That's the condition we learned earlier. So this is going to be 0.7 times 0.4 gives us 0.28. Right, B, property of B given C, which is the property of B and C over the property of C. B and C is 0.28 from part A. Property of C, as you can see here, is 0.4, like I said, this. So we get value of 0.7. C, property of A given not B. So just write in order. So this is going to be a property of A and not B over the property of not B. Right, A and not B, how do you work out? Well, if you were to once again draw this Venn diagram here, of A and B, right? A and not B will represent this section here, right? Okay, so we know already that property of A is 0.4, so this whole section is going to be 0.4, right? So it's going to be 0.4 minus the intersection point here, which we're given as 0.3, so minus 0.3 over property of not B, so that's going to be 1 minus property of B, so 1 minus 0.7, and we should get a value of a third. And finally, D, we're asked to find the property of B and C given not A. So this will be the property of B and C and not A over the property of not A. B and C and not A just represents just B and C, right? So B and C is 0.28 from part A over 1 minus property of not A is the property of A is 1 minus 0.4, which gives us a value of 7 over 15. Let's just try another one here. So we have John and Kaylee. They play darts in the same team. The events J and K are defined as follows. So J is when John wins and K is when Kaylee wins, and we're given it certain probabilities. So in part 8, find the property that both John and Kaylee win. So that means the property of J and K, right? So we know that we know there's addition formula, right? So we can say this is property of J plus the property of K minus the property of J union K, because we're given these values. So we got 0.6 plus 0.7 minus 0.8 like this, which gives us a value of 0.5. B, property that John wins the match given that Kaylee loses her. So we're trying to find J given K not K like this, which is the property of J and not K over the property of not K like so. Right, J and not K, once again, if you were to draw a Venn diagram, J, K like this, J and not K will represent this value here. So I can say it's this value of property of J minus this intersection point here, right? So property of J and K over 1 minus the property of K. Property of J we found as 0.6 minus the property of J and K, which we found in part A as 0.5 over 1 minus 0.7, which gives us a value of a third. Right, C, find the property that Kaylee wins a match given that John wins his. So we're trying to find property of K given that J wins as well. So property of K given J, which is the same thing as property of J, K and J. Just make sure you get the order right over the property of K. K and J is the same thing as J and K in part A. So it's 0.5 over Kaylee winning hers was 0.7 like this. So we're going to get 5 over 7 like so. And finally, determine whether the events J and K are statistically independent. So we worked out that the property of J and K was equal to 0.5, and we just have to show this by doing property of J times the property of K separately. So property of J was 0.6, property of K is 0.7, which gives us a property of 0.42. As you can see, 0.42 is not equal to 0.5, because this is the value we get using the addition formula, right? And that's the formula that value is correct for every single situation. And if they're not the same, then we can just say that it's not independent. Right, so in the previous video, we looked at a tree diagram, which looks something like this. But now we can label it with some given notations. So we have events A and not A. So this line here, this branch here, we can rewrite as the property of A, like this here, right? And this one will be the property of not A, like here. Now the second branch is the property of B happening given that A has happened. So this branch actually represents property of B given A. The one before will be the property of B not B given A. The second one will be property of B given not A. And this last one will be the property of B, not B given not A, like this. So you can now write or know what these branches actually represent in probability notation. And therefore, the final sections, this, if you were to go along here and here, this value would represent the property of B and A. This one would be the property of not B and A. This one will be property of B and not A. And finally, this one will be the property of not B and A. So this is just now, we can now write some proper notations to represent these tree diagrams. So let's try this final question here. So on a randomly chosen day, the properties that Bill travels to work by car, by bus, by train are these values respectively. The properties of being late when using these methods are also these values respectively. Draw a tree diagram. So in the beginning, Bill can travel by 3 methods of transport. You can do car, bus, and train. And the properties are 0.1, 0.6, and 0.3. Now, for each mode of transport, he can be late at a certain probability. So we're going to have late and not late for each one. Late and not late. And for being late by car, it's going to be 0.55. By bus, it's going to be 0.3. And by train, it's going to be 0.05. Meaning that the total probability has to equal to 1, right? So this branch is going to be 0.45, 0.7, and then 0.95, like this. So that's our tree diagram for this example. B, find the properties on a random chosen day. Bill travels by train and is late. So we're asked to find property of Bill being by train and being late. So T and L. Remember, T and L will be this section here, right? So we're going to go 0.3 times by 0.05, which gives us a value of 300 over 200. Part 2, property of Bill being late. Now, for Bill being late, we need to understand what are the different ways of being late, right? So the property of being late. So it can be late by going car and late, so that's going to be property of C and L. It can also be bus and late, so property of B and L. And finally, he can be late by train, so property of T and L, like this. So there's 3 different ways of being late. Property of car and late will be 0.1 times by 0.55. Property of bus and being late will be 0.6 times by 0.3. And the property to train and being late is actually the value we found from part 8, right? So there's 3 over 200. So adding them all up will give us the property of being late, which is equal to 0.25. Finally, given that Bill is late, find the property that he did not travel by car. So we're trying to find the property of not T given being late, which means it's going to be property of not T and late over the property of being late. The property of being late is what we find in part B, so we need to just find the property of not T and late. So that just represents being late without taking a train. So it can be late by car and it can be late by bus. So the property of being late by car is going to be 0.1 times 0.55, plus being late by bus would be 0.6 times 0.3, over the property of being late, which is 0.25, which gives us a value of 39 over 50. So as you can see, I can use these conditional probabilities to show it in a tree diagram as well.